In this video, we're going to explore the properties of logarithms. This is going to maybe give you a better idea of how logarithms can operate, just like we look for properties of exponents or properties of square roots, right? Now that we've sort of given you an introduction to the operation of a logarithm, this might develop that a little bit more. Okay, so a lot of these properties are based on similar properties or equivalent properties of exponents. So I want to sort of reveal that to you in a way, I guess. Okay, and all of them are probably proven in the textbook. The derivation and such is usually there. I'm not going to take time to do that, but I do want to sort of mention what it's based on as we go along. There are 7 properties. I think you can see those here. I already have them written out for you, so I'll just sort of talk through them real quick, and then we'll look at 2 types of exercises that you can use to help you practice what these properties do and how they work. Okay, so here's the first one. We have the logarithm of 2 things that are multiplied. So if you think about an equivalent property with exponents, right, it would be sort of based on this idea. If I had something like 2 to the 5th times 2 to the 3rd. What do I usually do with the exponents? I usually add them. So this is based on that idea, right? Each logarithm here represents an exponent. So if I'm multiplying, like I have x times y here, I'm adding the exponents. I can break it up as the log base a of x plus the log base a of y. Okay, the second property is division. If I divide 2 things with the same base, 2 expressions, usually I subtract the exponents. So this logarithm property is based on that idea. So I'm dividing here. So if I have the logarithm of 2 things that are divided, I can break it up as the log base a of x minus the log base a of y, much like the subtraction of exponents. Okay, the third one is a lot like number 1. If I didn't have a y, if I had x times x, or if I had any number of x's multiplied together, like x to a power. Okay, so then I would have log base a of x plus log base a of x plus log base a of x, like however many x's I had. All right, and this is sort of like repeated addition. So I could write them individually, or I could say, okay, I have an r of them, r times the log base a of x. That's the idea behind this property. So if I have an exponent, and I have to have everything in my logarithm that has that exponent applied to it, then I can bring that exponent out to the front as a multiplier, which is what we see here. Okay, these are the 3 that we're going to use the most, these first 3, and I will give you these on the test so that you don't have to memorize them. However, as you're practicing in this next week, I really feel like you'll probably already have them memorized, but I want you to be comfortable, so I will be giving those to you. Okay, 4 and 5 I think are pretty intuitive. You could use the idea of conversion here if you wanted to. A is my base. What exponent must I raise it to get A again? Yeah, a to the 1st power, right? That's the idea here. So, and also this is that canceling idea, right? My base of A and my log base A are going to cancel each other out, and I get the exponent 1. Okay, number 5, something similar, right? What exponent do I need to raise A to get 1? No matter what A is, anything raised to the 0 power is always 1. So that's the basis behind the 5th property we have here. Okay, the last 2 always look a little bit strange, but they're based on the idea of inverses. So because these 2 functions, a to the x and log base a of x, Because they are inverses of each other, I can do the composition. I can compose them together, substitute one into the other, and they should counteract each other and cancel each other out and give me back x. So property number 6 takes the function a to the x and substitute it into the log base a of x, so that I have the log base a of a to the x. So the base of a and the log base a are canceling each other out, and I'm left with just x. Okay, and then this is the other way around. The typing doesn't look that great here, so I apologize for that. But this would be substituting the log base a of x into the function a to the x as the exponent. So even though it looks backwards, a here is like this giant base, and I'm raising it to the power log base a of x. The log base a and the base of a still cancel each other out. It's in the reversed order, but that doesn't matter. They counteract each other, and I get back x. Okay, so there are 2 types of exercises that we can use to help us practice this. The first one is to take a logarithm and use the properties to break it out into its parts. So usually the directions say something like rewrite as a sum, difference, or product of logs. The sum, difference, or product really is referencing these first 3 properties, right? The sum, the difference, and the product. Okay, so I want to use those to take the logarithm I'm given and break it up as much as I can. So it's really good practice, or maybe to start out with these properties sitting right next to you, okay? And then eventually, as you're practicing and you're feeling confident, you could probably take your list away, right, and work without it. Okay, I'm going to try and keep the list here as long as I can. We'll see if we can fit everything on the screen. Let's start with the first one. We have the log base 2 of 2 times 3. Which property can we use to break this up? It's multiplied, so it's definitely this first property, right? So I can break this up as the log base 2 of 2 plus the log base 2 of 3. Okay, so I've used one property. Then I want to see, can I simplify this any further? I'm not using my calculator here. I'm just practicing with the properties right now. So I can do one more thing. Can you spot it? The log base 2 of 2, these match, right? The base of 2 and the log base 2. You could even think of this 2 as 2 to the first power. So they're going to cancel each other out. Really, this is property number 4. So this becomes a 1 plus the log base 2 of 3. And that's really as far as we can go with that, right? Maybe sometimes the exercises in the book will give you a value for log base 2 of 3, and then you could calculate from there if that's what they were asking. Okay, let's try the next one. This is a natural log, which means it's a log base e, but it still obeys all of these properties. So which property can we use here to break this up? It's division, so definitely property number 2. So this would be the natural log of e minus the natural log of x. Notice it's the numerator minus the denominator every time. Okay, this one may be a little bit harder to spot, but we can do one more thing. The natural log, even though we don't write it, it's sort of an implied base of e there. And this e is sort of like an e to the first. So almost the same type of canceling that we did here, we could do here. The natural log of e is 1. You could try that out in your calculator also, but it's definitely true. So this time we'll have the 1 minus the natural log of x. Okay, here's one more. Let's say we have the log base 3 of the square root of 5p over q. This one's a little bit longer, but it's the same operations. So we would want to start, I'm sure you can spot a few of the properties we're going to need. The question maybe is, which one should we use first? If I were to sort of evaluate this, which operation would I do last? I would do the division last. So in terms of breaking it up, I would want to break up that part first. I don't know if that makes sense, but okay. So I want to use property number 2 here again because I'm dividing. So I'll have the log base 3 of the square root of 5p minus the log base 3 of q. Okay. And this is kind of important. We need to deal with the square root next. So a square root is the same as an exponent of 1/2. So the square root of 5p, we could rewrite that as 5p raised to the 1/2 power. Okay, can you guess which property we would like to apply next? 1/2, because it's an exponent on everything that we have here inside this logarithm, we're going to use property number 3. So we can bring that exponent, it's like the r here, out to the front as a multiplier. So this becomes 1/2 times the log base 3 of 5p minus the log base 3 of q. Okay, we can use one more property and then maybe some simplifying. This 5p, these are multiplied, even though we don't usually write the multiplication symbol in between, they are multiplied. So property number 1 would be a good next step. Now because this logarithm is multiplied by 1/2, everything I break it into is also going to be multiplied by 1/2. So I'm going to write it first with parentheses, and then we'll distribute that 1/2 for the last step. Okay, I'm going to have to move this because it's going to be a little bit long. So I'll have 1/2 times the log base 3 of 5 plus, because I'm multiplying here, the log base 3 of p. I'm going to close my parentheses, minus the log base 3 of q. And then I want to distribute my 1/2. So I have 1/2 times the log base 3 of 5 plus 1/2 times the log base 3 of p minus the log base 3 of q. Okay, it's good to do problems of varying difficulty. This one definitely would be maybe on the harder side. All right, but it does, I hope, give you a good picture about how the properties of logarithm could be applied here. All right, we said there were 2 types of exercises. This is one type where we take a logarithm and we break it out into its parts. The other type of exercise is the opposite of this. We are given a list of parts and we want to use the properties in the opposite direction to build it back into one single logarithm. So let's take a look at that. Usually the directions say something like rewrite as a single log with coefficient 1. The coefficient 1 idea is sort of referring to property 3. So if I have any numbers out front of the logarithm, I want to bring them in as exponents so that I can further combine the logarithms I have. Okay, and so let's do these 2 examples. The bringing in the coefficients actually is a very good first step for this type of exercise. I can't really combine the logarithms the way they are with coefficients out front. It doesn't really fit the pattern that I see here. So I really need to bring in the 5 as an exponent on the a. And I need to bring in the 3 as an exponent on the b. Again, that's using property number 3. And then I can do one more thing. Which property can I use next? Yeah, number 1, because I have addition here. So if I have two logarithms that are added together, they do need to be the same base. Then I can combine them into one logarithm by multiplying their insides. What is the base here for these logarithms? It's not listed, so it's implied to be 10, right? We've talked about that. So they do match. So I can rewrite it as a single logarithm of a to the 5th times b cubed. So I've accomplished my goal, right? I've rewritten it as a single logarithm. Okay, let's try this second one down here. Similar process. You can see I have 3 parts this time. All of these 3 logarithms have coefficients though, so my first step is the same. I want to use property number 3 and bring the numbers out front in as an exponent. So this becomes the log base 7 of x squared plus the log base 7 of y to the 1/4 power minus the log base 7 of z to the 3rd. Okay, and then I want to combine them together. I usually do this from left to right. So if I want to combine these two together, which property should I use? Notice they're added, so I'm going to use property number 1, and I'm going to multiply the two things inside. It is good to notice that these are both log base 7, so I'm okay to do this. Okay, so I combined the first two. Now I can combine the third one. Which property should I use? It is subtracted here, so I'm going to use property number 2, and I'm going to divide what I have here in the parentheses by z cubed. This third logarithm is also base 7, which is probably worth noting to yourself. Okay, this is fine as an answer. I've combined it all into a single logarithm. If you would like to rewrite this 1/4 exponent as a 4th root of y, you could do that. Okay, that's definitely not a requirement, but those two things are equivalent. Okay, so I hope this has given you a good idea of what the properties are, how they operate, and what these two types of exercises look like so you can practice them a little bit. We're going to take this idea and apply it to solving equations in the next video, so it would be good to take a little bit of time to practice these properties so you can understand how all the logarithms can be combined together. All right, good luck.